In this lesson, we will cover Unit 5, Section 5.2, Properties of Functions. Question 1. Which set of ordered pairs represents a function? When looking at a question similar to this, we need to remember how an ordered pair represents a function. And in order to look at these options and decide, you need to realize that every element of the domain must have a separate element of the range. So as we go through the responses A, B, C, and D, we need to look for a repeated domain for each range. So in option A, 0 and 4, 0 and 6 are repeated. We can't have that. Same thing is happening in B, where we have 3 and 6 and 3 and 8. Again, C is very similar. We have 6 and 6, 6 and 4. The only option that has a separate range value for every domain element is D, 0 and 10, 3 and 8, 6 and 8, 9 and 4. The range value of 8 is repeated there, which is fine, since it has a separate domain element, because 3 and 6 are not the same element. So the answer for this one would be D. Question 2. For each relation below, determine whether the relation is a function and identify the domain and range of each relation. So in the first relation, we have a set of ordered pairs. In order to identify if this relation is a function, every domain must have a separate element for the range. So there cannot be any repeated elements of the range for the same domain element. So when we look through each ordered pair, 2 and 8, 3 and 12, 4, 16, 5 and 20. 2, 3, 4, and 5 each has a separate domain element, so none of the domain is repeated, which means that this relation is a function. Next, we want to actually identify the domain and the range. Keeping in mind that the domain is the independent variable and the range is a dependent variable. So the domain here in D is going to be a set of all the independent or X variables. So we have 2, 3, 4, and 5. And we're going to write that into our set notation for our domain. Our range, therefore, will just be the second element, which would be 8, 12, 16, and 20. The range is the dependent variable, or the X coordinate of our ordered pair. Next, in part B, we're looking at an arrow diagram where we have two ovals, and each oval represents something differently. And the relation itself is a number of wheels on A. So a particular bicycle or a particular item and how many wheels it actually has. That's how we're going to identify it. So in order for this relation to be a function, it is very similar to the set of ordered pairs in the previous question A. We are looking to see that every element in the first oval has its own separate element in the second oval, and that is not the case if you look at 2. 2 is going to a bicycle and a motorcycle, so that is not a function because every element of the domain does not have a separate range value. But we still can find the domain and a range, even though this is not a function. The domain is 1, 2, 3, and 4. So the domain of an oval is all the elements on the left in the first oval. And the range is everything in the second one. So we're just going to say bicycle, car, motorcycle, tricycle, and unicycle. So therefore our domain is on the left and our range is on the right.